So good morning, good afternoon, or good evening, depending on where you are, and welcome to this workshop brought to you by DeepFactor. My name is Cody, and welcome back to Techstrong Learning. We've got an exciting 90 minutes ahead, but before we get diving into things, I do have just a couple of housekeeping notes to review. First of all, today's session is being recorded, so if you'd like to watch again, follow along later, or share with others, you will be receiving a link via email that will grant you access to that on-demand recording. Now, I know this is going to be a lot of interaction today, so there's a couple of ways to do things. If you have general comments or thoughts, ideas, we do want you to send those into the chat. But if you do need any additional support, if you need some one-on-one help, we've got some people behind the scenes that are here to help you, and we just need you to send your questions into the Q&A. From there, we'll have somebody claim your question, and then you can get some direct help from there. So please don't hesitate to let us know if you need anything at all. Additionally, there is a handout in the handout section, but what I'm also going to do is just pin it here to the top because this is going to be a guide to our workshop today. Go ahead and download this, and you're going to have a lot of the essential information that you'll need to have a successful workshop with us today. Finally, before we close things out today, I will be giving away 2 $25 Amazon gift cards, so be sure to stick around to find out if you're one of our lucky winners. So our live workshop today is on SCA 2.0, using runtime analysis to find high-risk SCA vulnerabilities. And we've got a lot of people on the line today, but the people whose faces you're going to see on the screen today are Rizwan Merchant, VP of Engineering at DeepFactor, Kiran Committee, founder and CEO of DeepFactor, and Vikas Wadhwani, Director of Product Engineering at DeepFactor. So Rizwan, Kiran, and Vikas, thank you so much for joining us today on Techstrong Learning. Kiran, do you want to get us diving into what we'll be covering today?
Absolutely. Thank you, Cody, for that awesome introduction. It's great to meet you, everyone. I look forward to what promises to be an extremely exciting webinar and workshop. I'm going to switch to the slides. This is what we're going to talk about today. We're going to first take care of some logistics to make sure that you guys have all received pre-workshop prep material around some emails, how to join the Slack channel, and some other items that you would need to make sure that this workshop is successful. We're then going to spend a few minutes talking about the next generation of software composition analysis, how we can truly change the game with how we do SCA today and not let our developers get flooded by alert fatigue using a combination of static and runtime software composition analysis. Vikas is then going to walk you through a demonstration of how this would work with a real-world application, Bank of Anthos, in his demo environment. That way you guys get a chance to see how it would look like when you're finished with your actual workshop. We're then going to go through the workshop. Rizwan is going to lead you through the rest of the workshop material, where you'll be able to log into a DeepFactor portal. You should have received access to the test virtual machine that Rizwan's again going to cover. If you have any questions or if you're missing any material, please keep typing away at chat. We have a whole group of people here waiting to assist you. So one of the representatives from DeepFactor will jump in and help you with it. In the workshop, we're going to walk through how you can scan a container image for detecting vulnerabilities, something like what you would normally do with a static SCA. You will then run the application to understand and analyze it, to understand which ones of those vulnerable components are actually being loaded into memory and therefore reachable at runtime. And based on that, how you can correlate between the two and figure out, show a Venn diagram of what's important and vulnerable. And then in order to show this in real world environments, we're then going to show you a Kubernetes demonstration. We're then going to give you an interesting take-home assignment if you want to do this in your own time, at your own freedom. And then we're going to conclude it with some interesting giveaways and a free trial link, as well as some white papers that you can read in your spare time. So with that, let's get started. Cody's already done the introductions. So you've met the DeepFactor team. Rizwan is the head of Eng. Vikas is the head of product. And I'm the founder and CEO, and we have a whole bunch of Deep Factor members that are here that are going to be supporting you. We have Mike, Scott, Darshan, and Rutuja, 4 members that will be here, in addition to the 3 presenters today that will be here to assist you with the workshop. I'm going to pass it off to Rizwan for the prep items and logistics so that you guys have a smooth sailing rest of the workshop. Rizwan, please take it away.
Thank you, Kiran. So as Kiran mentioned, we are going to be onboarding all of you onto our Deep Factor platform. For that, you'll have to activate the account, and you would have received an email from Deep Factor with the heading Deep Factor Workshop has invited you to create Deep Factor account. There is an create account link. You can go ahead and click the create account link, and that will take you to the portal where it will ask you to set up your password and few additional details, and then you will be onboarded. So on the screen, what we have is a snippet of the email that you would have received. In case if you've not received that email, please feel free to reach out to one of our Deep Factor team members, and we'll assist you with getting you onboarded. That's as far as creating your Deep Factor account is concerned. The next set of prep item that you need to do, there is a virtual machine that's provisioned for each one of the attendees. And you will have to go ahead and log into that virtual machine using the username and the password that's shared with you in an email with the title Deep Factor SCA 2.0 Workshop Resources. So there are 2 emails. One is for activating your Deep Factor account. The other email, excuse me, the other email is Deep Factor SCA 2.0 Workshop Resources. Now, there are a bunch of resources that are included in this email. The first one is a link to the handbook, which is also uploaded onto this portal, onto this webinar session in the handout section. There is also a Slack channel that we've set up for you to reach out to Deep Factor folks. In case if you have any clarifying question, you can reach out to us on that, and we'll be happy to help you out there. There is also a Git repository for the application that we are going to be running in today's workshop. You can go ahead and download that as well. It has a bunch of take-home exercises as well. We'll cover all of that in detail as we move forward. And there is also the deployment YAML that we've provided for Kubernetes-based deployment. We'll cover all of these details in detail once we start with the workshop. So while we move forward with the demos and other things, you can go ahead and activate your Deep Factor account and try out the SSH credentials to log into your virtual machine. If anyone has any question, feel free to reach out, and we'll be ready to help you out with that. Thank you.
Awesome.
Kiran. Back to you.
Thank you, Rizwan. So, guys, in the next section, we're going to be spending 10 minutes talking about what is this next generation static and runtime software composition analysis. What we've created is a technology that truly can push the boundaries of what's possible with application security today. If we look at, for those of you that aren't as familiar with software composition analysis, what is software composition analysis? It is the ability to detect vulnerable third-party components that may be in your code or in your build artifacts, such as container images. Open source usage is everywhere. As we know, every software developer uses open source components these days to make sure that they're developing faster and not have to build all the modules in the product using their own code. In fact, some of the interesting statistics from Synopsys OSSRA report is that 50% of applications have high-risk vulnerabilities due to open source. So when you use open source, these open source components have vulnerabilities, and it's important for you to stay on top of which vulnerabilities you're bringing in so that you can ship secure software at the end of the day. An interesting stat is that 90% of applications today include at least one open source component that has had no development in the last couple of years, which is essentially telling us that the project is not being maintained, and therefore it represents a high security risk. So while it's extremely important to leverage open source to make sure that you can ship your software fast, it is also extremely important to make sure that you're constantly keeping track of the security vulnerabilities that you may be bringing because of this open source. And that is what software composition analysis tools will help you catch. The first generation of software composition analysis tools are highly noisy. if you think about what developers get, they get a large list of vulnerabilities. And I'm guessing many of you guys who have consumed or used first generation of software composition analysis for dependency scans or container scans are flooded with alerts and with no kind of guidance around what is important except for a severity score. And severity score is not the right way to determine the priority of these vulnerabilities, because it doesn't truly map to how your application is actually deployed. Just because something is highly severe, has a high severity, doesn't mean that it represents a risk to your organization. AppSec teams therefore end up being blamed for blocking releases because they give developers a whole bunch of vulnerabilities to fix and prioritize based on high severity. And guess what? A lot of the vulnerabilities that are reported have high severities. I believe the stat is close to 50% of vulnerabilities have crits and highs, essentially. So that means you are flooding your dev teams with alerts that may not truly be representing a risk to your business. And that leads to leadership team inaccurately determining the security posture of the application by simply relying on CVEs scores and inefficiently using their engineering resources by having them fix all of these vulnerabilities, especially when there's a new 0-day that comes up. Most engineering teams are frantically panicking to try and fix this 0-day that, usually during Thanksgiving or Christmas, vacations, it seems like. And that is something that can totally be avoided with a bit more maturity around how we handle our application security using a next generation approach that helps us narrow down what's truly representing the risk to the business as opposed to what has a high CVEs score. So the holy grail is if we can go from here's a total list of vulnerabilities, here's a total vulnerable components that you have in your container images and your dependencies, and these are the severe ones based on CVEs score. But if you can actually narrow that down to what is actually reachable and represents actual usage at runtime, you can significantly reduce the volume of noise and therefore prioritize the things that your developers need to fix first. We're not saying don't fix the other vulnerabilities. They're still important. And some organization policies might require you to fix everything that is greater than a certain severity level. But this gives you prioritization metric so you can truly understand what represents high risk to your business. There's a framework that we've created, and we call that the SCA 2.0 framework. There's a white paper that we've written on it, and that's something that we can share. I'll be sharing at the end of this presentation as well. The framework relies on 6 parameters to prioritize risk so that you can truly understand what SCA vulnerabilities represent the highest risk to your business. And this framework essentially relies on 6 items, whether it's the component is used at runtime and therefore actually reachable at runtime. Whether the vulnerable component is exploit. Is there an exploit available for an attacker to take advantage of that vulnerable component? Is there an active POC for the exploit? Is there an active incident for the exploit? So that'll tell you the maturity level of the exploit as well. What is the topology of the application? How is my application deployed? Is there an internet access exposed component? And of course, severity. Severity comes in 2 flavors, CVEs scores, as well as vendor-assigned severities, which sometimes differ from CVEs scores. And lastly, the applicability of the CVE. Let's say I'm using JDK 7. My CVE applies to JDK 8.5 and above. I shouldn't be worrying about the CVE as a high-risk CVE right this second. I can come back and fix it at a later time. So leveraging the 6 aspects of the framework is important. And one of the key things about making use of the 6 aspects of the framework is that you need visibility into not just the static artifacts of the application or the code of the application. You need to truly be able to see how the application is running in your dev, test, and production environments. And that is where Deep Factor comes in. So what we've created is 3 years of hard work, 14 plus patents in this area that allows you to scan your artifacts and code at build time. But equally importantly, it now allows you to examine how your application is running in your dev, test, and production environments. This allows you on the left to scan, left meaning left of the CI pipeline, to be able to scan your repositories or your container registries, or during the CI pipeline, your container images, to detect vulnerable components, vulnerable dependencies, vulnerable images, OS packages that have been installed in your container images, whether they have unwanted licenses, and create that bill of materials statically. But then at runtime, Deep Factor then observes these applications and containers for various parameters to understand and scan these components at runtime, detect which of the vulnerable components are actually being loaded into memory, understand whether there's any risks that are being exhibited by these applications as they're running that may not be known CVEs on the left. So essentially catch unknown vulnerabilities that may become 0 days tomorrow. And then, of course, correlate the two, static and runtime insights, to give you a Venn diagram of, hey, look, you have 1,000 things that are vulnerable in your 7 microservices. However, 50 of them represent the highest risk because we know for a fact they're reachable and they're actually loaded into memory by your application when we ran the application for 3 days in your dev test and staging environment to do the baselining. Defactor then integrates into all of the aspects that represent your CI pipeline so that you can get to use the product without having to leave your tools of choice. So if you're able to achieve this, the way you think of software composition and application security in general changes. And each of the parties, developers, application security people, and leadership will significantly benefit because now they're not just looking at CVSS scores and saying, hey, I'm going to fix these things. Instead, they're truly understanding, okay, CVSS scores indicate a certain number of vulnerabilities, but what represents true risk to my organization is a subset of those vulnerabilities. And you can tier these risks based on the different vectors that I gave you. And Vikas is going to show you a demonstration of that as well. That results in a much more pointed activity that engineering teams can go through without being flooded by alert fatigue and spend time on what truly represents risk to the business, as opposed to checking boxes because something has a high CVSS score. AppSec teams become heroes because they're telling devs not to fix everything, but telling devs truly what represents risk to the business, and therefore having the engineering teams focus on that effort. And when a new 0 day comes about, this level of maturity is truly going to change how an organization approaches a 0 day. You're no longer going to be panicking about every single instance of that vulnerable component that exists everywhere in your artifacts, but instead you'll say, hey, look, I know, OpenSSL or Log4j exists in 500 places, but these 20 places represent the highest risk because of the 6 parameters of SCA: reachability, applicability, exploit maturity, all of that. And therefore, I'm going to look at that subset first and fix them first. Then I'm going to have my engineering team take the Thanksgiving or Christmas break and then come back and fix the remaining vulnerability. So it adds a degree of maturity to your organization that results in AppSec and engineering teams working together very well. And from a leadership perspective, leadership ends up tracking the true risk to the business as opposed to just a bunch of vulnerabilities in their dashboards. And what that means is they will make sure that the engineering team and the AppSec teams is spending time on the right things that represents actual risk to the business, as opposed to a large list of vulnerabilities for the sake of cutting the count. That's a quick overview of how this next generation of software composition analysis powered by runtime visibility can help you. And in order to see this in action, I'm going to have Vikas give you a demonstration of how this technology would work with an actual live application called Bank of Anthos. Vikas, take it away.
Hello, everyone. Hey, thank you, Kiran, for outlining the SCA 2.0 framework. I think it's awesome, and we are going to see it in action now. I'm going to share my screen. By now, you guys should be seeing my screen. For the purpose of this demo, I'm going to use Bank of Anthos application. This is an open source application originally created by Google. It is composed of around 10 microservices written in different languages, as you can see here, right? And this is the application dashboard. And this is split into 2 panes. If you see here, the right pane talks about runtime security alerts. You will see more of this in the workshop, which Rizwan will conduct. But this is, we discover a lot of insecure behaviors that happen at runtime, and we can alert you whenever we detect such insecure behaviors. But for the purpose of this particular demo, I'll concentrate on the left half. The left half shows not only SCA and SBOM, but it also enriches that information with the SCA 2.0 framework that Kiran outlined. Right? I'll touch upon a few, and I'll show you how we can prioritize true risk to your application through this easy to use intuitive UI. Right? So the top half talks about container scans. Right? So we've found that there are 1,928 OS packages in this small, medium-sized application, right? It's just 10 microservices. That's a large number. Then if you look at this particular red bubble in the Venn diagram, you can see that it's 965 of them are vulnerable. Right? And SCA 1.0 tools sort of gave you this list. And this list was very hard to contend for AppSec teams as well as developer teams, right? So there was always a tussle between developers and AppSec teams. So now with the SCA 2.0 framework, let's see how we can prioritize or bring down this number and get to the top hit list, right? So you can see that there is a blue bubble, which is basically the used. This deep factor has detected that you've used only 119 of your 1928 OS packages, right? And on top of that, only 2 of them actually have an exploit available, right? So this is like your P0 list. You get these fixed in your current sprint, right? And then you concentrate on the 72 that are used and vulnerable, right? So now we've created a mature plan for us to reduce our true risk to the application rather than just looking at a long list of 965 vulnerable OS packages, then relying only on a single CVEs score, right? Similarly, for your application dependencies, right, you can see that we have Java, Node, and Python, and this red bar represents the vulnerable Java packages, right? And if you look, 51 are vulnerable and used, whereas 39 are vulnerable but not used at all, right? So you can concentrate on the 51 first because for a fact they're used in runtime, right? And that increases the exploit capability of these vulnerability, right? Another conversation that you can have with your DevOps or your developer teams is, I see a bunch of stuff that is not used, right? So here you can clearly see that there is a room for us to pick a slimmer base image, which has lesser number of OS packages, and you can reduce your attack surface area drastically, right? Similarly, we provide this information for Node and Python, right? Let's dive a little deeper into each of these topics, right? So first, let's go to OS packages, right? We saw that there were 1928 total OS packages, right? And let's filter them down. Let's see how many vulnerable do we have. 965, right? And then I'm going to see how many of those are actually used at runtime. You can see that the number comes down to 72. That's a good number. Let's bring that down further, right? And you can see 2 of them actually have an exploit available in the wild, right? Makes it very easy for attackers to exploit this particular vulnerability. Now let's take an example that a lot of us will remember. I'm sure OpenSSL gave us all some sleepless nights, right? So let's look at OpenSSL, right? We have 13 instances of OpenSSL, right, across different container images that make up this application. Now let's see how many of those are actually vulnerable. 12, right? So there is one version of OpenSSL which is not vulnerable. That is great, right? So we brought the number down to 12. Let's see how many of them are indeed loaded. None of them, right? So it is possibly just there in your base image, right? But your application doesn't need it, right? So instead of trying to upgrade it, fix it, the best recommendation is to just find a different base image or remove it from your base image altogether, right? So you saw how we, in a structured fashion, we were able to answer questions that we would have liked to answer when this vulnerability came out. Am I using OpenSSL? What containers have OpenSSL? Are those applications using OpenSSL, right? So all of these questions can be answered simply by playing with these filters once you have this data. Now let's do a similar exercise for dependencies, right? The starting number is 1,326. Let's see how many of them are vulnerable. Number drops significantly to 166. That's good. but it's still a large number. We cannot expect developers to fix 120 or upgrade 166 dependencies. So let's see how many of them are loaded. 93, we sort of dropped to half, which is good, right? And let's see how many of them have exploit available. 12, right? So this is a great number to start with, right? Let's just go fix these 12 in the current release or in the next release, and then let's target the 93. This way we are reducing the risk drastically, right? Even though you may fix only 12, the reduction in risk is massive. Again, let's take a real world example. Let's look at Log4j. Right? Another one of those vulnerabilities that ends up on a long weekend, right? We see we have 15 instances of Log4j, right? So 15 artifacts have Log4j. How many of those are vulnerable? 3, right? And how many of those are loaded? All 3, right? So we need to go fix all 3 of them. Right? And Defactor lets you go one level deeper, right? Many times what happens is the CVE description will have the vulnerable function name or the vulnerable class name. So let's say this number was large and you're unable to fix it immediately, right? What you can do is go one level deeper and see if you're indeed using the class, the vulnerable class or the vulnerable function that is mentioned in the CVE. If you're not, then you get some more breathing room, right? While the library in itself is loaded, I don't see that the vulnerable function is getting used by my application. A similar exercise, a similar drill down can be done for OS packages as well. Now let's look at libpython, right? For example, and then you can see when you click on usage, you can see all the list of shared objects within that particular OS package that were indeed opened during runtime, right? So this framework is making it very easy for you to prioritize risk. Now, tying this all back into this powerful representation where we can identify where the true risk is rather than concentrating on a large number of vulnerabilities that has marred SCA for ages, right? So this new framework is providing a structured, matured approach to SCA and reducing true risk. That's it from my side. If there are any questions, please feel free to post them on chat. Somebody from our team will answer them, and we can also take some questions on video at the end. Over to you, Kiran.
Awesome. Thank you, Vikas. That was a great demo. Let's now move to the next aspect of this, which is the workshop itself. So I'm going to pass it on to Rizwan. Rizwan, please take it away with the workshop.
Thank you, Kiran. Thanks, Vikas, for the awesome demo. I'll go ahead and post some commands in the chat window that we are going to be using while we run the workshop. So let me go ahead and pin that to the top. My apologies. This is not really coming out the way I wanted it. But nonetheless, we still have those commands in the chat. The pin section doesn't look that great, but at least you can run the commands. But you also have a handbook that can be used for this, for going through these commands. So let me go ahead and share my screen, and then we'll take it from there. Give me 1 second.
There should be a link to the handbook in the handouts section.
Right. So you guys see my screen okay? Are you able to see my screen okay?
Yes.
Yes.
All right, cool. Okay. So let's get started. You all should have received the email as we mentioned earlier. You need to go ahead and activate your account on Defactor portal. Once you click on the create account link, that will take you to the registration dashboard, the login page, where your email address, and you need to set a password. Password is minimum 14 characters with the complexity that's mentioned here. And go ahead and set a password so that we can get going. In the meantime, I request all of you to also go ahead and activate your accounts so that you can follow me with different commands that I'm going to be executing, and you can follow me on that. Okay, all right. So I'm able to log in. If anyone has any difficulty, feel free to reach out to one of our team members and we'll assist you. I'll go ahead and click the login button here. And as soon as I log in, it takes me to the login screen. I use my email address and the password that was used for registration. All right. As soon as I log in, it takes me to the page where I can go to my website, and it will present me with the dashboard over here. Now, this is the start screen where, right now I don't have any configuration set in my account. I don't have any applications that are scanned, container images or that are scanned, and also no applications are running right now. So that's the reason why, because it's a clean slate, it gives me a brief description and a start button. The moment I hit start, it will give me 3 different options. Now, the first option is scan container images for vulnerability. That is going to be our focus today. The second option is finding vulnerability in your Kubernetes workloads. We'll have a demo of that after the workshop. And the third section is running your container images or building your integrating the defactor into your CI pipeline, adding defactor for your container build, or running standalone application, non-containerized applications. For this demo, we're going to be focusing on scan container images for vulnerabilities. Are you guys with me? All right. I'm going to go ahead and click Start Setup. The moment I hit Start Setup, it gives me an option for exporting the run token. Now, run token is required for scanning your container images or project files or running your applications, either be it in defactor, webhook, or standalone. We will need the run token for all the workflows that we're going to be doing today. Go ahead and copy this for me. And we need to execute this command in the virtual machine that's set up for the demo. Now, you also should, as I mentioned, you also would have received an email with details on how to log into the virtual machine that's set up for this demo. Each participant has one virtual machine that's set up for them, and you have credentials that are shared with you. You can use those credentials to log into the virtual machine. I have a terminal where I'm going to be executing these commands. This is my virtual machine. I would request all of you to go ahead and log into your virtual machine to execute the commands. All right, so I'm in. Now here I will be running some commands where I will be scanning the container image and running the Docker container application, Dockerized container application, and we'll go through the insights on the static side as well as on the runtime side. Let me go ahead and execute export run token command. That's the first command that needs to be executed. The second command that we will execute is to scan the container image. Again, the details are in the handout, and also the details are shared in the chat window that's pinned to this that's pinned on the chat window session. All right, I'll go ahead and run the scan, DSCTL scan, and the container image. The moment I hit enter, it starts pulling the image and it performs the registration with the platform. It downloads a bunch of DB files and runs the scan. Let's look how it actually shows up on my portal. The moment the scan is initiated, the artifacts dashboard will show the currently scanned results. Now on my terminal window, I can see my scan has completed, and the results will be posted onto the portal. Here you can see the results are coming in. I can see there are 52 alerts that are generated for this specific container image, and the results are still getting processed where all the details will be populated in a short while. It takes about a minute or so for the results to get posted. A brief background about what this application is. It's a Spring Boot application. It's a damn vulnerable Spring Boot application with few additions that Defactor has done. It's a demo application, and this application has a bunch of Java. It's a bunch of Java dependencies and OS dependencies. We'll go through all of those details as soon as the results are done processing and the results are completed. Is there any question from anyone that we can take in the meantime, specifically for this, specifically for what we've done so far? Okay, all right. So let's see if my scans are complete. It's still getting processed. Let us go over the alerts that we have so far. There are a bunch of alerts that are posted, specifically with regards to Java. Okay, so here we can see that in this specific containerized application, there are 65 dependencies, and this being a Java application, these are 65 Java dependencies. Also, there are 146 OS packages. As you can see, there are multiple tabs that provides you more details about this specific container image. There is a layers tab, which gives you details about different layers that make up this container image. There is a base image. There are multiple settings that are done. There are packages that are being installed as part of the container build. Then there is a list of vulnerabilities that exist in this specific container image. There are overall 381 vulnerabilities that includes OS packages as well as Java vulnerabilities. We can go ahead and select the target. If I'm interested only in Java vulnerabilities, I can select them. So now the number goes down from 381 to 135. There are 135 vulnerability in the Java packages, 65 Java packages that are used by this application. You can also select only OS packages dependencies. I'm sorry. You can also go to the SBOM detail, where you can select it based on the severity, type of dependencies, target, whether the package is vulnerable or not. So if let's say that, and then whether there is an exploit available in the wild, as Vikas touched upon, that this could be a very important factor for us to prioritize fixing the vulnerable packages which has exploit available in the wild. We also provide information about whether the dependency is transitive, is a direct dependency, or you can also select the ones that the vulnerabilities that exist only in the base images, or the packages that are part of the base images. We'll come to workloads in a bit. This information will get populated as soon as we launch the application. But scan history, here you can provide, you get the details about how your application across multiple builds have been trending, and you can select a specific version to get more details there. All right, let's see. Okay, my scan is complete and all the data is populated. Now, the next step that I'm going to be doing is I'm going to run this application with dfactor. Awesome. Let me go ahead and click the start button one more time. I'm going to be selecting, I'm going to be selecting this. And here you need to make sure that your run token is set, which is already there in this specific window. And then you need to run the command to launch the application. The command that we will use to launch the application in this workshop is already shared. You can go ahead and run that command, and we'll see how that application gets reported into the portal. Okay, let me copy the command. All right. Not what I want. Right, so this command, it's launching the image, it's running the image that we just scanned, DBSPA 1.0.0. The bunch of parameters that are used to register the application with the portal. So any Docker run command that you have needs to be prepended with these 3 minimum parameters, whether you want to run, what is the application name, what is the Java component name, and then your regular Docker run command follows. This will launch the application with dfactor. Let me go ahead and run this application, this container. Oops, 1 second. Oh, this is the it has to be dash name. Just make sure that this is correct. Let me go ahead and correct that here. Okay. All right, so if you can see, my container is up and running. And I should be able to see this in the application's dashboard. Since the application name I have used is one Spring Boot app, this is how it shows up over here. If I click on this, there are 2 different sections that we show. The left part is runtime enriched SCA and SBOM details. And the right time is runtime security alerts. As soon as the telemetry flows in and the data is processed by the platform, which takes about a minute or so, this information will dig more deep into the different information that's displayed in both of these sections. All right. In the meantime, if there are any questions, feel free to let them come in. We'll help you out with any questions. I want to go back to artifacts page and show you that this is, once the application is running and the data is processed, the artifacts that we just scanned will show what workloads are running this specific artifact. You may have 1, 2, or maybe hundreds of different applications using this specific container image, and all of that will show up over here while the application is running. All right. Again, here, since this is a single container deployment in a Docker environment, the deployment mode is shown as Docker. In case if you are deploying it in a Kubernetes environment, this will show and report that this application is running in Kubernetes.
Hey, Rizwan,
Also,
you might increase the browser size a little bit.
sorry about that. Is this clear?
Yeah, thank you.
Thanks, Vikas. All right. Now, since this is a single container application that we ran, there's one component here which shows that there is one component registered. And let's see that if this is marked as an active instance. So yes, the telemetry is coming in, and we've started processing it. And now it is showing that this is an active instance running in the environment. Let's see how the overview page looks like now. So as I mentioned, there are two sections. Left section gives you details about runtime, enrich, SCA, and SBOM. The top part of the left section is specifically for OS packages, while the bottom section is for application dependencies. In case if your applications are use multiple languages, for example, if it's a Kubernetes environment, multiple container images form the application, then all of those dependencies will show up over here. And this was very evident in the Bank of Anthos application demo by Vikas. In the OS packages section, there are overall 146 OS packages. Well, there's one that has exploit available, but that's not used by this application. Well, there's one which is used and is vulnerable, but there's no exploit available for this one. But nonetheless, this is high priority enough because it's a vulnerable package and used by your application. You should go ahead and fix it right away. While there are 72 vulnerable packages which are not used by the application. So as to improve the sanity of this application, you can go ahead and remove those vulnerable packages which are never used by the application. Let me go ahead and click on the used one. Here I can see that this is a libc package, libc6, which is used by Java component. All right, so here it tells me the 146 OS packages. I can select them based on whether the package is vulnerable or not, whether there's an exploit available or not. As we said, there is one package which has exploit available but not used. I can find out all the vulnerable packages that are part of the base image. So here I can see that there are 96 packages which are part of the base image, while there are 50 of them that got added as part of the build process. We have similar information available for dependencies as well. Here, because this is a single container Java application, the target that is shown here is only Java. If there are multiple languages that are used to develop the application, you'll have a list of all the applications, and you can select only the ones specific for a language in using this filter. Whether your dependencies are vulnerable or not, here you can see there are 20 dependencies that are vulnerable. Let's see how many of these have exploit available. I can see there are 5 out of 65 that have exploit available. And if these are used by the if these are used by the application, then that increases the priority that I need to make sure my applications do not. I mean, these vulnerabilities, these packages are patched so that these vulnerabilities do not exist in my because there are active exploit available and the application also. So that's the highest severity that we should go ahead and fix it on priority. Perfect. We can also see whether these dependencies are transitive or direct. Awesome. Let's spend a little time on the runtime alerts. Now, the right section is runtime security alerts, where it tells me while the application is running, what insecure behavior as part of my container image, my insecure behavior executed by the application that could potentially be a 0-day today, I mean, a 0-day vulnerability in future. Now here we can see this container application has an uncommon or risky environment variable, which is a secret key that's probably used for something, maybe accessing some resource or something like that, which is which is a not a good practice. And ideally, we should be having secrets stored in a vault or and fetched it at runtime. Also, you can see that the Java process here is running as root. So at runtime, Defactor will monitor every process that's running in your container image. So in case if there is any exploit that gets executed as part of your application at runtime, Defactor will monitor that. And there are 11 different categories that are used to gauge the insecure behavior of your application. And all of these are configurable through alert policies. We'll go over that in a bit. I hope everyone is able to run the applications. And in case if there is any question or any help that you guys need, feel free to reach out to the team, and we are here to help you out with that. All right, okay, cool. So let's go to the next section. As I mentioned, when an application is running with Defactor, specifically, let's say a container running with Defactor, any process that gets executed inside that container will be monitored by Defactor. So any external shell or any probe that comes in that executes some malicious behavior, if you're making an outbound network connection to a geolocation that is forbidden, Defactor will monitor all of that and generate an alert. Let's do a simple test and see how my overview page will change if I'm executing some commands inside the container. There is a next set of commands that we have shared. Now, I'm going to be doing a Docker exec in this container image that's running, the container application that's running. All right, okay. So what I have done is I have got a shell prompt on the container image, and I'm going to be executing some command. Let's say that I just want to find out what all is there in this container. Okay, so when I do find, it basically dumps everything that's part of this container image. Now, as I mentioned, every activity, every process that is launched inside this container is monitored by Defactor. So the shell that we created is monitored by Defactor. The find command that we ran is monitored by Defactor. And all the files that were read will be monitored by Defactor and reported to the platform. Now, platform takes maybe about a minute to kind of process that data. But as soon as the data is processed, if there are any additional packages that got loaded as part of this process, the OS package Venn diagram and the dependency diagram, dependency details will change accordingly. At the same time, runtime alerts, if there are any additional runtime alerts, that will also start showing up on the right side of this panel. If there are any questions, feel free to reach out to us. We are here to help you out with that. All right, let's see whether data is available. Not yet. Okay, are there any questions? All right, so now you can see as the data came in and that was processed, my Venn diagram is looking very different now. I do have 4 used vulnerable packages, which are currently used by the application after the commands that I executed. There is libc, libpcre, libinfo, and bash. All right. And as you can see, there are also some additional runtime alerts, and these runtime alerts are specifically for the new commands that we executed in the container. There's an additional shell that was running as root, so there is an alert for that. Find command was running as root. There are some unsafe string APIs that were used by the application. So we have more details and from the runtime behavior of the application. All right, cool. Any questions, feel free to reach out, and we are here. This brings me to the end of my workshop. I hope that everyone was able to follow up with me and run those commands. The portal login will be available for longer duration. We'll discuss that as well. And also there are some take-home exercises where you can try some more in your environment by running some applications in Kubernetes, or maybe what we've done so far, you can repeat the same exercise in your own environment. Thank you. Over to you.
Awesome.
Kevin.
Yeah, thank you, Rizwan. That was an awesome workshop. As Rizwan mentioned, a few housekeeping items. If you guys have, please join the Slack channel for additional questions as you continue through this workshop and even after the workshop to reach out to us. Next, we're going to show how this entire application would, this concept of observing runtime analysis would work in a Kubernetes environment. So far, what you've seen is a simple single container application because we wanted to keep the workshop simple. What Rizwan has been able to demonstrate so far and what you guys followed along with in the workshop so far is you were able to perform a static SCA scan on a container image. It's a single container application that was an intentionally vulnerable application. So it detected vulnerabilities and known CVEs in both the container images as well as dependencies. Then Rizwan demonstrated how you ran the application with Deep Factor. The single container image was run. Deep Factor analyzed which vulnerable components were actually used at runtime, therefore representing a higher risk to the application. Rizwan then exercised the application with some sample payloads so that more code paths in the application was exercised, and therefore you could see more components or aspects of the applications that were reachable and used. And the Venn diagram that he demonstrated showed how vulnerable components were overlaid on top of used and reachable components, as well as exploit availability, so that you could prioritize the items that represented the highest risk. In addition, what he also demonstrated was how the application insecure behaviors were detected through runtime analysis. That was a second module on top of runtime software composition analysis. Runtime security analysis then detected insecure behaviors that were hiding in this application, like certain processes running as root, certain environment variables exchanging sensitive information, and he quickly demonstrated some of the other rules that the product showed around 11 categories of misbehavior, ranging from privilege escalation to buffer overflows to insecure network behavior, so on and so forth. There's a bunch of rules that the tool then checked against this application to determine insecure behaviors. Now, the interesting thing to note is while CVEs are detected by SCA scans, both static or runtime, runtime analysis can help you detect malicious or insecure behaviors in your applications that may not be CVEs. So simply doing a static SCA might not help you catch certain bad things. For example, your application may be reaching out and making an outbound call to certain geography, North Korea, for example, or it may be touching certain parts of the file system like etc password, or it may be doing SCP or telnet to certain locations. These may not be CVEs today, but they could be vulnerable behaviors exhibited by your applications that is important for you to catch. Next, what we're going to show is, well, we're going to, in real world environments, you're not just going to have one container. You're going to have multiple containers in a Kubernetes environment. So what we have is a fantastic, easy Kubernetes webhook that can be used to observe Kubernetes workloads as well and get the same exact functionality that you've seen with a more complex application. Vikas is going to show that in the next part of the demo. Vikas, take it away.
Hey, thank you, Kiran. Thank you, Rizwan, for the session. I'll quickly share my screen. Right, so Rizwan went through scanning a single container, running that single container, and correlating the results. But as Kiran mentioned, in real-world applications are more complex than a single container. They may be deployed in different methods, right? So we'll see how deep factor can work in the various deployment modes, right? We went through a single container method, right? So you guys were able to follow, you were able to scan that container, you were able to run that container with deep factor. Similarly, if your application is non-containerized, right, pretty much the instructions remain similar. It's a three-step process. You export your run token, you install dfctl in the participant's case. This is already pre-installed, so you can skip this step. And then you ran the container as part of the workshop. But if you were to, if you were launching a non-container application, all you had to do was replace -- docker run with -- cmd, and you could launch your application. That's it. All you need to do is prefix your launch command with dfctl. Right? You don't need to install any agent, daemon, none of that stuff. Right? Now, you could have containers, but you may be using some sort of a container orchestration tool. For example, you could be deploying in Elastic Container Service on AWS, or you could be launching your container in a Lambda function, right? You could be doing serverless with containers. For such scenarios, what deep factor provides is a Docker file that runs a multi-stage build. So you can see we run a multi-stage build and we add our interception library to your container image, and we give you a deep factor enabled container image. Now that container image is portable, you can use it, you can launch it anywhere, and deep factor will start observing the runtime behavior of that particular running container, right? And this is a great way for enabling deep factor in environments where you don't have access to the underlying host, or you don't have access to some sort of a webhook access, which we will see in the case of Kubernetes, right? Now, Kubernetes is very popular today in terms of deployment, right? So, and most of you would have seen that Kubernetes deployments can turn really complex really fast. You may be deploying hundreds to thousands of pods, right? So asking users to hand edit pods was a complete no-no. So we've implemented a very seamless way for deep factor to be injected into your containers is by a admission webhook controller, right? So what that webhook does is that it intercepts every pod that gets created, right? And it looks at the configuration you've set, And if the config says that this needs to be observed by defactor, it injects the defactor interception library into the container without any intervention from the DevOps team or the application developers team, right? So effectively, as we will see in the demo, in a matter of minutes, you can start observing your entire cluster with defactor. And on top of that, what we also install as part of our Helm charts is a static scan pod in your Kubernetes cluster, right? While you can integrate this scan pod in the CI pipeline, right? If you can use it to gate builds, you can get early feedback for your developers. There might be container images that you're pulling in from third-party registries, right? Which is, or there some other containers that are not being built as part of your CI pipeline, but they still run in your Kubernetes cluster and they represent risk to you, right? So even those need to be scanned, right? So we have a static scan pod, which again automatically listens to pod create, and if that container image has not already been scanned by defactor, goes ahead and scans it as well, right? So what now let's see how we can install this, right? How seamless it is to install this. So this is the portal that you guys have access to, right? And I have Kubernetes. I have a machine where I already have Kubernetes installed. I have Helm installed, right? I have kubectl installed, right? So let's start installing defactor Helm charts, right? So first step, we are trying to add the defactor Helm charts. Let's see our Helm repo ls. There are no repositories as of now. Let's go ahead and add the defactor repository, right? Let's check if that worked. Helm repo ls. Yes. So now we have defactor Helm repository added, right? Now, I mentioned that we can scan your container images, right? But in order to do so, if you're using an authenticated registry, we need access, right? We need credentials, and you can pass those credentials securely via a Kubernetes secret, right? And in this particular machine, I already have my credentials. Generally, they're located at, in your home.docker config, right? So you can see this file exists, right? So I'm going to quickly create a secret. First step is to create a namespace. Let's create a df webhook namespace. And within that namespace, we will create a secret. As you can see, we are doing a kubectl create secret. And from file, and the file location that we saw was home vikas.docker/config.qc. Right. So now the secret is created. We're good. Let's jump to the next step. Now, in this step, we are going to generate override.yaml, which will be passed to your Helm charts. In order to make this process very simple, all you need to do is provide a name. So let's say I'm going to call this my workshop cluster, right? And there are a bunch of advanced options. We don't, most of them, they're same default, so we don't need to mess with them. I'm going to copy the contents of this particular file, but if you actually click, it also downloads it. I don't want to SCP, so I will just create a file here called webhook override.yaml. Let's paste the contents that I copied from the UI. That's it, right? And now the next step is to just install our Helm charts. So you can see the Helm charts are getting installed. We can get the status, right? All our pods get installed in the df-webhook namespace. So you can see both of them are running around, right? And as I mentioned, one is our mutating webhook, which intercepts your pod creates and adds the defactor interception library. And the second thing is the second pod is the static scan pod, which is responsible for scanning your container images that come up as part of your pods. Okay, now let's do next. As you can see, the webhook has registered with the portal. So the portal says, everything looks good. Let's start observing namespaces. Now let's start observing. I'm going to create a namespace called BOFA, which is short for Bank of Anthos. It's the same application I used in my first demo. Right? We want to scan as well as we want to observe the runtime behavior. So I'm going to say both. We have a whole lot of options for you to customize the behavior of deep factor within your cluster. You can selectively include pods that you want deep factor to scan or observe. You can also exclude certain pods that you don't want deep factor to scan or observe. You can change the alert policy. For now, I'm just going to go with defaults. For the runtime behavior, what I want to do is I don't want every pod to become a different application, right? So we are deploying our entire application in a single namespace. So I'm going to use the namespace option here, right? All pods in the namespace will be part of the same application. So let's override this and say that my namespace is my application. And I do add namespace, right? So that's it. So what we've done now is we've told deep factor, hey, start observing and scanning the pods that come up in the BOFA namespace. Okay. So let's go here and actually create that namespace. Create ns BOFA. Now, in order for me to deploy this application, I need to create a secret, this BOFA application. And it takes generally about a minute or up to 2 minutes for this configuration to be pulled by the webhook. So we'll just give it a minute. Right. So, and while we are here, I can walk you through how easy it is to add more and more namespaces. We have a cluster configuration, which you can decide your alert policy, or you can decide your exclusion criteria. And every time you add a namespace, you don't need to reconfigure it. The cluster config is automatically inherited for every namespace, and it's applied. So right. So I have the deployment YAMLs for this particular application already present in this particular machine. So you can see there are a bunch of YAML files. A lot of these are basically deployment, Kubernetes deployments. Right. So let's quickly open, let's say, user scripts. Right. So you can see this is a of kind of deployment. It is deploying a particular image, right? And this image is coming from a private registry, right? So let's go ahead and deploy these, right? By now the configuration should have stuck. Now we are deploying this. Now let's see, you can see BOFA, right? All of these are now getting are coming up. By the way, deep factor does not install any sidecars, any host agents, right? So all we do is we inject an init container, which adds the interception library to your container. So it's very seamless, and the overhead is also very low because we don't add any sidecars, right? So let's go back to our applications and see. You can see that BOFA has come up, right? And you can see it has like 5 components. And as I mentioned, we told deep factor that all the pods that come within this particular namespace should be grouped into this particular application. So that's what is happening. All of these pods that are coming up are lumped into this particular application. So you get an application aware view. You don't have to go artifact by artifact to get a application level view. Right now, you can see the no scans have been performed. What will happen is also deep factor will start performing scans against these container images of the pods that are getting launched, right? So no action needed. Deep factor will start scanning images that came up. Deep factor will start observing the runtime behavior of your applications. So you go ahead, start running your tests. Whether you have automated test, manual test, and deep factor is observing all the time. And this dashboard will get richer and richer as you use your application, right? So this is and eventually will reach here, right? after all the scans are done, after we've discovered runtime security alerts, you'll start seeing it. But there is no manual user intervention needed to achieve any of this. So in a matter of 5 to 10 minutes, you can have your entire Kubernetes cluster being observed by deep factor, and you can get the risk posture for your entire Kubernetes, for all the applications running in your Kubernetes cluster.
Awesome.
Over to you, Kiran. Thanks.
Perfect. That was a fantastic demo, guys. The question, you can keep typing away more questions in the chat. So our team is still continuing to watch for questions on the chat window. So please ask away. The next part of the question, I think we have 15 minutes left. So we have a couple of interesting things here. Next thing is a take-home assignment that Rizwan has for you guys, so that you can take advantage of this, even after the workshop is done. And Rizwan, you can walk the users to through the take-home assignment.
Thank you, Kiran. Thanks, Vikas, for the awesome demo. What we are going to be doing in take-home assignment is what was demoed by Vikas. We want you to go ahead and try out the Kubernetes-based deployment. So the demo that Vikas did to how to deploy webhook in your Kubernetes cluster, and go ahead and configure that so that you can observe namespaces, and any deployment in that namespace will be automatically monitored by deep factor. So there are 3 things that I have here. First of all, we have a GitHub repository where all the applications and the samples that we've walked you through it in today's workshop. That repository is available. You can go ahead and clone that repository. That contains a specific section on Kubernetes deployments. So the first thing is go ahead and clone the application using the command git clone. The next is, after deploying the webhook, like how Vikas demoed, you can go ahead and configure the webhook to monitor specific namespaces. And from the clone repository, you can go to the directory named k8s and execute the command kubectl apply -f the YAML file in one of the monitored namespace. What this will do is, specifically, this is a single container deployment, but you can have multiple containers as well for your other applications. What you could do is execute this command and observe the way application is coming up with all the init containers and how the application starts showing up in deep factor portal. And you can monitor the deployment using kubectl get pods -n monitored namespaces. So 3 simple steps to exercise what was demoed by Vikas, and deploy the same application we did for in the workshop in your Kubernetes environment.
Awesome. And Rizwan, do you want to remind users to join the Slack channel, and what is the best way for them to get the handout? The email that was sent to them is where they can get the handout, right?
Yes. Thanks, Kiran, for reminding. So the email that was sent to you earlier that we discussed right in the beginning of this session, it contains few resources. The first one is, of course, linked to the take-home assignments. At the same time, it also contains links to join our Slack. You feel free to join deep factor Slack channel. You have any question, we are here to help you out with that. Feel free to post questions that you have with regards to what we did today, or in case if, let's say, you want to try it out, some of your other Kubernetes applications, feel free to deploy. And if you have any questions, concerns, let us know, and we'll be happy to help you out with that. Awesome. At the same time, the handbook that we did is also the link provided in the email. Handbook can be also downloaded from there.
Perfect. Thank you, Rizwan. So guys, we're going to spend the next 5 minutes concluding this, and I'll also give you a couple of QR codes so you can download some white papers as well as links to the trial, etc., in case you want to continue your application security journey with the next generation of application security platform like Deep Factor. What we've covered today is the following 5 use cases that next generation application security platform like Deep Factor can help with. One, and going from dev to prod, left to right, generation of bill of materials. scanning your container images, scanning your non-container applications, your code to generate CycloneDX and SPDX bill of materials, especially important if our company needs to comply with the presidential mandate for SBOMs. Scanning your container images, scanning for third-party open source dependencies, etc. Doing that with the scan, CLI tool that we have, that can be embedded into your CI pipeline, etc. Runtime SCA, which is truly unique, which is the ability to understand which of the vulnerable components are actually being used at runtime and presenting that Venn diagram that truly presents the risk. That together makes up this bucket of tooling that is truly extending the boundaries of what's possible with AppSec today, and that falls under the umbrella of next generation software composition analysis. Interesting thing to note is Deep Factor product. If you go to our product page, pricing page on the website, etc., it's divided in such a way that if you want to use Deep Factor for the static scan and runtime, you can. However, if you have a favorite static SCA tool that you want to use and you want to just use Deep Factor for the runtime part, you can totally do that. It's very flexible. You can pick and choose which modules you like and want to use, and we completely coexist with any other tool that you may have in the industry. Following the journey of the artifact along, Deep Factor then performs runtime analysis. And Rizwan briefly touched upon it and showed you the 11 categories of misbehavior that you may be able to detect in your applications. Sometimes those types of behaviors might not be CVEs, and therefore your SAST or SCA tools on the left might not catch them. Runtime analysis will help you detect these types of bad network behaviors, bad DNS activity, bad file system activity or memory activity that your application may exist. And you can catch those types of bad behaviors in dev and test and staging in pre-production environments if you want to truly detect and improve your AppSec posture ahead of time. If you want to leave it on in production environments for true container runtime security, primarily for SOC 2 or other compliance type reasons, you can do so as well. Items 3 through 5 would fall under this bucket of next generation container runtime security. So whether your goal is to have next generation software composition analysis or AppSec, or whether your goal is to have next generation container runtime security, the tooling provided today can help with both. Here are a couple of QR codes that you can use as a takeaway. If you'd like to play with the product by yourself, you get a 14-day free trial. You can reach out to the Deep Factor staff, go to Deep Factor website or scan the QR code, and you should be able to take advantage of that. You can test with your own applications to see, get a sense of the kinds of risks that Deep Factor might find in your application, as well as to get a sense of how you can prioritize your software composition analysis findings based on what risks truly represent higher risk to your enterprise, because based on what's actually being used in memory. You'll be able to play with all of that with this trial. The QR code on the right is a SCA 2.0 white paper that our research team has created that will help you understand a bit more detail into the 6 parameters that we use to determine risk prioritization for your software composition analysis findings based on whether it's reachable, whether a vulnerable component is actually used in memory, is it applicable to your environment, is there exploit maturity related information, so on and so forth. So there's a lot of meat in that white paper that could make a fantastic read. It goes really well with coffee on a Saturday morning, so give it a try. And lastly, if there's any questions that you have that you missed today that you wanted to ask, or you couldn't receive one of our pre-workshop prep emails for some reason, or you don't have the link to join our Slack channel, please reach out to us, hello@deepfactor.io or support@deepfactor.io, and our team is going to be more than happy to help you out with your application security journey. Thank you so much. Cody and the Techstrong team, back over to you.
Awesome. Well, Rizwan, Kiran, and Vikas, thank you so much for joining us today. That was such an awesome workshop. And Kiran, could you actually bring those slides back up? I want to have those QR codes up while I close out, just in case anyone didn't get the chance to grab those.
Yeah, okay, let me do that.
Perfect. Thank you so much. So while I have these QR codes up on the screen, I would like to take this time to remind everyone that the session was recorded. Following this program, you will be receiving an email with a link to access that recording on demand, or you can find it living on the Security Boulevard website. That's securityboulevard.com/webinars. The two winners of our $25 Amazon gift card drawing are Cheng-Su J and Iran K. So congratulations to both of you. Keep an eye on your email. You'll be receiving an email from me shortly to get this gift card over to you. But if you don't happen to see that email, check your spam folder on the off case that it gets filtered out. I'd like to thank Deep Factor for sponsoring this workshop today. I'd like to thank our audience for their participation, their questions, their feedback, all of your engagement today. I think today's workshop has been an awesome success. And of course, if you do have any more questions for Deep Factor, that's hello@deepfactor.io. Rizwan, Kieran, Vikas, thank you all once more. It was such a pleasure having you on here with us on Techstrong Learning.
Thank you, Techstrong team, for the opportunity.
Thank you, Cody.
All right, thanks again, everyone. You may now disconnect. And at the top of the chat, there is a link to our survey. Feel free to fill that out for us.